let me take another function is there, which is g x plus vt. Right, now I have got two such functions. Number one is right, fx minus vt, and here we have g x plus vt. Right, so I don't know whether this is a solution yet, so you can't just out of nowhere, you can't just find solutions like that. So I'm going to find whether this is a solution, right? So what I'm going to do is, for simplicity, I'm going to take this as u, yeah, x minus vt is u, and x plus vt is w, right? So I have now here y is equal to fu plus gw, and u and w are functions that depends on x and t. V is a constant. We already know what the v is, that is velocity, right? And right, if you're not familiar with these terms, so I think I should right, put it aside, because if you're not very familiar with these terms, it's my responsibility to introduce these terms to you. Number one is, there's something called wave number. In high school we mostly deal with wavelength and the frequency, but here we use them, but up to some extent in quantum mechanics we prefer to use wave number as well as the omega, in the sense angular velocity, rather than a frequency directly. So wave number k is represented, k is just introduced as 2 pi over lambda, which is wavelength, and on the other side we have frequency, or you can say omega, which is angular frequency, is equal to 2 pi f. Those are not new stuff. I mean, this is not a new equation at all, right? So even in one of my A-level video series, this is explained, so you can go through that video if you are interested. So this is not a big deal. So then I can, yeah, so what about this now? We know another one. So the velocity is equal to f lambda. So what if I go ahead and substitute these values? So f is now 2, yeah, so here I can say omega, no, let me rearrange a bit. So when I rearrange them, I will end up with here lambda